Computer. Right, we're recording. All right, guys, everyone. We've been coordinating on Slack quite well. Fraser and a few of the other guys have been trying to tackle the joys that is Kaggle's kernel infrastructure. Unfortunately, we found that it's not exactly the most enjoyable experience. It runs on a very anemic virtual machine that only has 2 virtual CPUs. If you remember from last week, I was suggesting that the minimum that you would use would probably be an 8-core system. The reason for that is that you can attach, I suppose it's a bit like putting the Ferrari's engine inside a Skoda. It's going to run faster than a Skoda, but it's not going to run as fast as a Ferrari with a Ferrari engine. And what they've done is effectively attached a very small virtual machine to a very powerful GPU, which means that if you've done any performance testing, you know that you look for the bottleneck, and the bottleneck for this is the I/O and the CPU's ability to serve data to the GPU. So the GPU is sitting underutilized the vast majority of the time, or if you use a batch size like I did, which was higher to fill the GPU load went up, but it went up and it spiked up and down, while it was waiting for the I/O to fill it again. So it's not a great place to do your training at all. The only reason I think you would probably want to do the training on the Kaggle kernels is some of the competitions force you to use the kernel, and that's a decision they're making to level the playing field. So those competitions tend not to allow you to use pre-trained models, because if you could use a pre-trained model, you would just dive off onto another platform, train like mad on that one, and then drop your trained model back onto Kaggle's infrastructure, which is effectively what we ended up doing. So what I'll do is I'll give you a quick whistle-stop tour of how the Kaggle system's working. So you can see the model that we did, I've made public because I think it's kind of useful starter for fast AI. And I don't think anyone's going to cheat with it because it's producing a score of like 0.65, whereas the other one that's been shared, this ResNet 50 PyTorch one, that the Praxitum Yandex people did, and as you can see, a lot of people have copied it and got exactly the same score of 0.699. I don't see any real value in doing that. If all you're doing is executing somebody else's notebook, you're not really learning anything. And the point of this whole exercise is to learn. But you can see as well, some of the people that have been doing it have branched off from the model that they were given, and they actually are achieving some pretty good scores. One of the senior guys in their team looks like they're in third position, which even for a competition this small is pretty good. Okay, so the big things that we learned over the week was that for kernel only competitions, you can't just use the Kaggle API to submit your submission.csv file. That is a bit frustrating because when you're running on Kaggle's infrastructure, they give you what's called a GPU quota. So you get a certain number of hours of GPU a week, and I've burnt all mine. So they gave me an extra 2 hours that you're supposed to only have 30 hours. So they cut me off at 32 hours and 31 minutes. And I've got to wait another 30 hours before I get any more GPU back again. So that's something to watch out for. One of the when I did some research after this, one of the suggestions is if you're running a notebook and looking at it, and you're also submitting a notebook, you're actually generating 2 virtual machines. So your GPU hour quota is basically burning at double rate. So yeah, you've got to be quite careful about husbanding your GPU quota if you're trying to create a competitive model in a kernel competition. So if we go to my work, this is one of the notebooks, and I'll be able to launch it because I've stuck it into CPU only mode, which works fine for inference, to be honest. So, oh, hide self view, and oh, and make this small so that we can get this out of the way so it's not going to get in the way of the video. Right, as you can see here, it's actually got quite a good version management system, and what it does is it shows you the last saved version of your notebook. So you can see here it's got all the output in it that you would expect, and what it does at the end is it shows you the data that it uses. So you can see here I've used the imet collection 2020 dataset, which is the one that we downloaded. Now, the advantage of kernels is that if you link a dataset from the Kaggle, a Kaggle hosted competition, you don't actually have to download it. It's already on their servers. So that does actually save you a bit of time. The other thing that you can do is you can link other data sets in if the competition allows it. And that's basically what I've done to allow me to get a pre-trained ResNet 34 model in. And you can also see the output files. So what I've done is I've outputted the submission CSV, I've exported the model in completeness, and I've also outputted the two different stages. So once you've done that, what you can do is you can click on the submission.csv and you can click submit to competition. What it does then is it reruns your entire notebook and generates a score if it runs successfully. And then that basically creates your public score for your leaderboard. It's a bit convoluted, but to be honest, the system actually works fairly well. You can also look at the previous versions. You can see here this one crashed with a timeout. There's hard limitations on the length of time that the VMs can run. They're very similar to the collaboratory restrictions. So don't try running anything that's more than like 7 or 8 hours on this system. Likely you'll see it timeout and fail. Aiming for something about 10,000 to 12,000 seconds seems to be the sweet spot where they tend not to fail. And giving your kernel a decent name is probably a good idea as well. I went with kernel random generation for the first 13 versions, then thought, well, I should probably give it a good name. Right, so the bits that were I thought the most well, not most complicated or most non-intuitive is if you scroll down here. This basically is exactly the same as the example that we trained last week, but I had to make some changes. Let's see. So this is basically the cheeky bit. So getting your pre-trained model to start with no internet. Just remember, when we run Fast AI, one of the good advantages of it is that it basically automates a lot of things. So grabbing the latest version of ResNet 34, we didn't actually see happening. It just did it automatically for it. However, when you're operating in an environment where you've got to be able to reproduce it without having access to the internet, those jobs fail. So what I've done is I've connected up a new data set. So you can add data sets to your Kaggle notebook. The way you find them is if you search data sets. So you go into data, and if you type in something like, this was the recent one, we were trying to find one for ResNet 101. You type that in and search. What's going on there? I'll just type it in. ResNet 101. And you can see here that there's some people that have kindly uploaded the PTH files. So what I do is I just found a more recent one that had less models in it. This one's quite good because it's got an awful lot of pre-trained models in it. So you might be able to just attach that one to everything you use. But I think the one we were trying was this one for ResNet 101. And you can see inside it, the data source, the only thing that it's got is the PTH file. If you remember, that's the saved weights and parameters and biases and all that sort of stuff that makes the neural network actually able to work. So it doesn't contain the structure, but it contains all the magic numbers that let it do its magic. So if we go back to notebooks and transfer learning and edit.
Is that allowed to import weights if it's not allowed to use anything pre-trained? Isn't that the same?
It depends on the competition's rules. That's one of the things that you really need to check, which we didn't. I wasn't aware this is a kernel competition, and until we actually tried to submit the weights. Each of the competitions can have their own rules. Some of them are heavily restrictive and don't allow you to do any pre-trained weights at all. You've got to do everything sort of hand coded. So you can see here we've got the input for ResNet 34 Fast AI. So that's someone else's uploaded the weights, and this is me creating a data set for my transfer learn an adapted version of ResNet 34 that's been trained on the imet 2020 data. If you expand them, you can see they basically behave like a normal file system. If we scroll over here, you can see that the steps for copying. So you basically make the directory that the FastAI would have downloaded it into, which is the torch cache directory. And then you copy the file out of the input directory into the directory that it expects. The one thing that caught me out here was that this small section of numbers and letters, that I think is the version number. And what our system will do, because it's got the latest version of FastAI, is it will ask for the latest version of ResNet. We might not have the latest version of ResNet, but what we want to make sure is that the system thinks that we have. So what I've been doing is I basically ran this and caused it to crash, and it told me that it couldn't find the file with this name. And then I copied and pasted that value out of the error into the second parameter of the copy command. And that seemed to work quite well. I also then, after I'd done my initial training, I copied the ones from my data set. So if we go back, I'll show you how to create the data set. So if you go to data and create a new data set, it's basically drag and drop. You drop your PTH file into here and you give your data set a title. That's all there is to it. There's no more magic. So anyway, that's pretty much what I learned over the course of the week. The other things that was maybe worth mentioning is, I don't know if you noticed that the one of the options for downloading your weights off of the Jupyter Notebook when we were doing our training on GCP, downloading these 100 megabyte files either by the SSH or downloading via Jupyter Notebooks was taking maybe 10 or 15 minutes to copy across a 100 megabyte file, which is pretty appalling. I tried doing it a different way after that. Basically, if you run gcloud init, what it does is it creates the GSUtils commands, which are the Google Cloud Service ones. And then what you can do is if you create a bucket on Google Cloud, which is it's the same sort of thing as that you get in S3, and you can copy your file directly into your bucket, and then you can download from your bucket. Because it's copying directly from Google platform to another Google platform, this only takes like seconds. And then because you're downloading from the bucket directly to your machine, it runs at however fast your network speed is. It's incredibly quick. So definitely worth looking into this if you're using Google Cloud services. I think you're probably not going to see exactly the same behavior, but if you're running on, if you're running it in like SageMaker, it's going to encourage you to push all your models into S3 anyway, and you can download exceptionally quick off of S3. So that was the other thing that I found out this week. So what I was going to suggest is we could pass over to Ellis, and maybe he can show us about the other things that he's been doing, and show us some of the cool tools he was talking about, like was it pmap and some of the other optimizations. We can maybe try and get them working on our notebook.
Yeah, thanks. I just wanted to share a few things, and I actually found a short talk that I gave last year at EuroPython, and I'm sort of just taking that as the baseline and showing you through a few things. But if you have any questions, make it interactive, ask stuff. We can just try to run this and get you some programming. So the original talk was all about functional programming and how to do that in Python. I'm not going to go into all the depth. I just want to show a few tools that are kind of ported from the functional programming world. So yeah, what I used here as an example is just to get started was in some cases you define classes like this, which are kind of unnecessarily complex because you have to write a bunch of boilerplate, then you have to initialize and run your functions, when really all you want to do is run a function. So it's all about the right tools for the job, but I'm going to skip a bit of this or maybe come back to it later, because what I really want to show is the concept of MapReduce. You've probably heard of Hadoop, which is underlying a few other things, and that's the paradigm, and it comes straight from the functional programming world, where what you try to do is limit shared context, because if you limit shared context between like different functions, different threads, etc., then you can just let them run at maximum speed and you don't need to synchronize between them. So that's basically the core idea under MapReduce, is try to split up the work so that the packages of work that you split up can be processed individually, and you don't actually need to synchronize anything between them. And just to showcase that or get to there, what I did here was just show this typical for loop that every one of us has written before. You have a bunch of inputs, and then you kind of want to have an output for each input that you created. So you create a for loop over it, you calculate your individual result, you append it to some output array that you had before, and then finally you have everything that you wanted. That is a bit tedious, but it works. It's fine. It's easy to write because it's in some sense how we think. But yeah, Python has a couple of built-ins that are super useful for this. One are these list comprehensions, where you basically just write a for loop in line. That has the, in my opinion, big advantage that for simple things like this, you don't need these variables. You don't need to append. You don't need to write all these separate lines. And more importantly, it's safer in a sense, because this result is not automatically reset in every for loop. So if you forget to clear up something there, you're gonna have it in the next loop. And if you tried this in depth, you might have found that in some cases you've had like still the result of the previous loop, and things got really messy really quickly. So that's why I really like this way of expressing it. It's also very short, and it kind of reads nicely. The alternative, and now we're slowly getting to the parallel world, or towards it, is called a map. Now, what's important about map is it's basically a for loop over something, so over inputs, let's say, and the for loop consists of only one function call. So you would take all of this here out, write it into a function, or into a lambda as I did here, and just say map over this function. So in other words, execute this function for each element in these inputs and give me the result. Does that make any sense? Okay.
Yep. Makes sense.
Cool. So the cool thing here is, because you're not creating any variables that Python thinks may have other context, I'm simplifying it a little bit, but because you're not creating anything that needs a lot of context, each iteration of this is actually complete. You can completely isolate it. And that's what we're using when we take this to the next step, which is pmap, so a parallel map. Yeah, here all I'm doing is I'm taking that lambda out and making it a separate function. But yeah, and you can, filter is similar. You apply this filter function, and then you only keep the elements that sort of pass this test in this function. Similar for reduce. The real cool thing I found is if you then apply this to parallel processing, because I've got this function here, I can run it in a regular for loop, or in this case, list comprehension. And because I've put a sleep one here, this takes 1 second per iteration. So running this takes 10 seconds, obviously. I can express the same with the map function, as I've said before. But if I just do that, it still takes 10 seconds because it just runs one after another. And that's where this pmap is really cool, because, sorry, you see 10 seconds. The pmap does the same thing as the map, but it uses multiple threads. So you can actually, at least for like asynchronous stuff, never mind for a second, you can actually save a lot of time by just saying, instead of mapping over it, pmap over that, which will send it to different threads, and boom, I'm down to 1 second, because it just span up 10 threads, each of them running one iteration of this. And importantly, it collected them all in the right order again, which is normally not what you have in parallel processing. So pmap is very clever there. Now, I did mention that last week, and there was a very good counter argument that was, well, you're not going to get very far with threads if we're running at 100% of our CPU. So I posted this little util here, which is my implementation of a pmap function using multi-processing. So now we're spinning up separate processes instead of just separate threads, which means we just get more mileage in that regard. So I can try and run that with this function, and this should probably take like 2 seconds plus a bit of overhead. Because now I'm utilizing all the cores or vCPUs that I have. And here I'm saying, yeah, use up to 6 processes. I can obviously tweak that. But this is really the important thing that I think wanted to get to last week, where some of the stuff that we were doing was taking really, really long, and we were using a lot of CPU time of one CPU core. And we can use it. I've shared this in the group, so we can just use this function to extract our results or work with our results in a much faster way. And that thing is really the main thing that I wanted to show. If people are interested, I can get a little bit into some really cool data manipulation tools with a Z. Yes, that's not my fault. If you're interested in that, I think they're very neat and very, very clever.
Yeah, I certainly would be. That tip with map, I think, would have really sped up what we did last week, because we were sitting, we'd already generated all the predictions, and all we were doing was trying to change them so that we could have an output that was usable. I mean, it was just basic processing that was holding us back.
Yeah, that's exactly what it's for. So the other things that I have are not about faster processing in that sense, but more about shorter, more expressive code. So are people interested in that as well?
I would be, yeah.
Okay, cool.
Yes.
Then,
even if it's just so that we can understand the code you write.
yeah. The weird thing is I use these so much that I find code written with them much easier to read than other code. So you have to stop me if something is unclear. Yeah, sorry. And but by the way, I think these tools are largely from people who come from a functional programming background in Lisp or so, but who've had their fair share of parentheses, and they kind of wanted to use a slick programming language like Python, but with some of the powerful concepts from Lisp, and they create this package. So obviously you just do pip install tools. And what I find where it's really strong is in dictionary manipulation. So you might have a straightforward dictionary like this, but then maybe you want to apply something to all of its keys or all of its values. Maybe you need to, like I do here, add a postfix, or you want to multiply all the values by 10, or whatever it is you want to do. Maybe you want to turn those all into a file name. And there it's got these really powerful variants of map for dictionaries. So key map means apply this function that I'm giving to you, in this case, this formatting function, to each key, so each of these strings in the dictionary, then take those keys with those original values of the dictionary and give that whole thing back to me as a changed dictionary. So I can do that, and I get everything with this underscore post at the end, like I've written here. So really powerful, because if I wanted to write that in a list comprehension, I would probably do something like this of the key to value for key and value in the dot items. So I'm getting pretty verbose here, and this is, I find, is really ugly to read. It takes, admittedly, takes some getting used to, but just saying, oh yeah, take all the keys and format them with post at the end, that's much more concise and I find easier to read. Similarly, you have the val map, which means value map, obviously, where you could say, well, just take everything and multiply it with 100. And that's exactly what it does. You can obviously, like I said, take that further for file names, and say, maybe what I really want to do with those numbers is I want to create a file called my file such and such, let's say. CSV or something like that. And boom, you've got your files. Also very cool there. Actually, make sure that when you install pmap, install Python pmap. There is another pmap as well, but the Python pmap, it follows the same idea, and you get pkeymap and pvalmap. So we're really nesting those together now. And all I need to do here is run pvalmap, and this whole thing that I'm doing here is suddenly posted through multiple threads, and it's gonna run much faster as well. I just gotta import it from pmap. Boom. So yeah, you can do the same with valmap as well. Does that make sense? Is that useful?
Yeah, definitely looks useful. I mean, obviously, one of the things that we regularly see is big long lists of files that that we need to postpend the PNG or something onto. So that would be perfect for that.
Yeah. But speaking of that one, there is actually a really cool way to do that in pandas as well. If I if I can try and build that on the fly. So say you have a data frame where you've got a column, I don't know, just call it target, and maybe 1, 2, 3 are your values. So you've got something like this, but then you can, maybe you want to turn those all into file names and append PNG. So first of all, to do that, I actually need to take those targets and turn them into strings. With brackets, you can neatly chain these things, by the way. So, right, this is a dictionary that I need to pass. So you can say, turn this into the string data type. And then you can maybe say assign, so create a new column in this data frame, which we call file name. And it takes this data frame that we have here with the strings back in, takes the target. And there are some, on each data frame, there are these str for string manipulation things. And I hope I can get this right. Oh, it doesn't have, thought it did.
It's on a series.
Yeah, it's on the series. So, thought we had the format there. I mean, okay, formatting is not directly on there. In that case, we can instead just use apply and say, well, something.png, the N key is a bit dodgy, but the Apple Store is closed. Dot format, which is a function that we can use. And there you've got your file names. So you can actually do the same thing in pandas as well. Pandas is clever as well in how it applies that, because yeah, I actually don't know in which ways, but I do know that it is. It's got something to do with the C implementation of some pieces underneath. Don't know if that applies to this, but yeah, so you can do the same thing in the Panda as well. So if it's already in a data table, in a data frame, use it like this. What else do we have here? Yeah, group by, also a classic. We all know group by from databases, where yeah, we want to sum things up, for example, by supplier ID or by a target image or whatever. So in this case, group by just means building the groups. There is no reduce built in, which you normally have, or which you have in the database world. But I can just say, yeah, take all these numbers, in this case 1 to 8, and group them by whether they're even or not. And then I get false for the odd ones, true for the even ones. You could see maybe we want to split that by the actual target that we have in a classifier. So say you've got a data set and maybe 3 target classes, and you want to just split it by the target class, then you could use this group by. Or again, if it's in pandas, you have an equivalent there with data frame dot group by. Yeah, I'm going to spare you the merge. It basically just takes 2 dictionaries together. If you're interested, have a look at the tools library. It's really one of my favorites. Yeah, and I think the rest of this is a bit of a deeper dive into some functional things. I did at some point write a whole tutorial about how to use pandas in a functional way. And I'm just gonna say a few words about that, because I find that really, really useful. And that is, never use in place. So if you have any functions like, I don't know, maybe you have a data frame and you would normally say drop index. And a lot of people do basically this. They take a data frame, drop the index, maybe set a new index. Call it ID, again, in place, true. This has a lot of problems. Just a second. Okay, sorry about that. So that has a number of problems when you work in Jupyter Notebooks, I find, because if you run this cell twice, you're going to get a different result. And if you're anything like me with Jupyter Notebooks, you are going to go back and rerun cells somewhere earlier in the notebook. And if you write code like this, then it's going to get messy whether you want or not. Similarly, if you just say, I don't know, my column is df 1 to the power of 2 or something like that. So you're changing this data frame in place, basically. The alternative to that is to just chain things, which actually I find makes the code nicer to read as well, because you can sort of follow the path that the data frame takes. So you can say, well, I'm going to take this data frame, I'm going to drop the index, and that returns a new data frame with the index dropped, but it doesn't actually change the original. And then I can chain more things on here, and I can say, well, now set the index ID. Again, don't do it in place. Now this whole thing returns a data frame where we dropped the original index and we set a new index to ID. That's what we're getting back, but we still not changed this original df. And then the last thing I want to show with that is a sign, which basically does this here in the same sort of fashion. And we just say my column equals, and then the calculation, just in a second. So what a sign does is it creates or overrides a column, but again, only in the data frame that you're getting back. It doesn't touch the original. So you could, for example, say df new is this, and you could be absolutely confident that the df you have here at the top is absolutely unchanged, which means you can always rerun this cell in your notebook as often as you want, because it doesn't do any harm, and this just works. Now, the only tweak that we need to do here at the end to this is if you want to respect all the stuff that you've done here before, then you gotta give it a function of a data frame that returns something here. So this is the properly chained expression. And you see with the brackets, you can similarly, like maybe if you've ever worked with JavaScript, similar like there, you get these nice chains and you see, okay, this whole operation here is something that we do to this one data frame, some clear instructions on how to process. We get some output, we can rerun it, it's reproducible. We can share this snippet of code with anyone because this here is all without context, so you can apply this same step, the same code to any other data frame without messing up any code. And that is exactly what I like about this idea of chaining and functional programming, and a lot of these concepts coming from there. You can just keep things clean, prevent bugs, and hopefully write better code. That's
really, really nice. I've got to admit, I'd taken on board the concept of always build a new data frame as you move down. It allows you to, if you realize you could have done something better and you go a third of the way back up your notebook, you can make that change and just execute from the third down. You don't need to rerun all.
Exactly.
I would have done what you've done there though over 4 lines, and I would have had 4 new data frames getting created, and that's just so much cleaner.
Yeah. Well, you can always like split it up into lines if you want to see the intermediate results, but most of the times I find you don't really care about the results in between. So you want to just build it step by step. So maybe first execute this, then execute this, see the intermediate result ones, build this step by step, because you can rerun it, right? So you can just always add steps until you get out what you want. And then you can keep.
Is that more memory efficient as well? Because you're not going to have the other data frame variables lying around.
It can be. Depends a bit on the context. Depends a bit on which type of copy you're doing. Because Panda is very clever. So even when you create a new data frame by doing like df copy and things like that, it can be very clever about still pointing to the same data. So it's not really easy to say. It probably doesn't make a big difference, but it does make your code cleaner.
Oh, that's awesome. Thanks for that, Ellis. I'm definitely going to be using a lot of those tips in future. You've totally changed the way I'm going to write Python. Hopefully other people are feeling the same way. All right, I guess let's turn off the mutes, and should we decide what we want to do next, or do we just want to call it a short one because it's bank holiday and we can all go and drink beer? The thing I would be keen to do is over the course of the week use up some of our time to actually form a Kaggle team. and let's try training the model. And my real goal is to get above all those 6.999 people who've just executed a public notebook. And I think that would be a really good win for us as a ML club. And then maybe next week we could have a look at the results for that. And I'd quite like to look at Deep Racer again, because all through this month they're giving us free access to the console. It's an easy way to do it, but it's also quite it's quite expensive if you continue to do it. There are cheaper ways to train Deep Racer models. So anyway, that's what I was considering. Does anyone else have any ideas or where they want this to go?
Sounds good to me. Yeah, be good to see this museums Kaggle one through a bit longer and see if we can do a bit better. But yeah, Deep Racer sounds interesting. I don't know a whole lot about it, so that'd be good.
Okay, well, I've got a pack that I've done before for ML Club that I can run again. And in that last one I did for the AWS meetup, I managed to get a model trained and driving around the track in about 45 minutes. So that should be a good, easy way to do it. Okay, right, well, shall we call it a night tonight? Just make it a 1 hour meeting, and as I say, we'll catch up on Slack, and we'll try and share the models that we're building and share results, and maybe join us into a team rather than as individual entries when the team merger deadline approaches.
Yeah, sounds good.
Yeah, sounds good.
Oh,
Yeah.
perfect. Right. Well, Elliot's really impressive input there. I think that's one of the things I'm going to take away this week is I'm going to try and convert that really slow running submission CSV script cell, and I'm going to swap that over and hopefully get it running in pmap.
Yeah, try using the pmap that I posted on the Slack channel, because that's multi-processing. The other one is multi-threading only, so you're going to be faster with that. Also, if anyone has questions about this stuff, or even just remarks or want to tell me I'm wrong, either of those, shoot me a message on Slack. I really enjoy this topic.
No, thank you, Elias. Have you? I arrived late, so sorry. Have you shown also the tqdm library?
No, I actually did show tqdm when I first gave that talk, but not this time. Well, when I gave the full thing as an actual talk, but
Right.
yeah.
Okay, thanks.
But we can jump back into that. I can show that next time or whenever.
Yeah, we can do it next time. Don't worry. I just I've used it a bit, and I thought it was good to show that it's pretty good library.
Yeah.
But we can do it next time.
Yeah, I mean, if people want to stay on 5 more minutes, I can even show it now. I mean, I've got the notebook still running.
Yeah,
Anyway.
I'd be up for that.
All right, let's do that then. By the way, this is running on Binder based on this full thing. I can send the link around. Like I said, this is what I shared last year on the EuroPython, and you can play around with those notebooks yourself. So what you want to do is import tqdm, or I think actually you want to import auto. Okay. Have I been kicked out of my session? Ah, now it's working. Okay. Actually, you probably want to just import tqdm. And really what we're doing then is, I'm going to just take this example with the timing from before, and not the parallel one, because progress bar and parallel bar processing doesn't really go together. So I'm just going to take this same function here. So this took 10 seconds to run, right? Come on. Sorry about that. I'm just gonna have to rerun the imports here. I should be okay to go. Yeah. Okay, so this takes 10 seconds to run, just mapping over it. But we don't see what happens in between, right? We just see, well, it starts, it takes a while, and then it took 10 seconds. So what you can do instead, it's actually as simple as saying tqdm dot, I'm just going to use auto because that's the version that works in Jupyter, and you just let that run.
I think I usually do from tqdm.auto import tqdm.
Yeah, sorry. I get a bit confused because there is like several things in there. So this should be the one. Thank you for that.
Yeah, sorry.
And then what you do is you get a progress bar, just like that. So basically it looks at what you've got here, notices this is of length 10. And then for every iteration it updates it, knowing, okay, I've got to go to 10. So after one iteration, you're at 10%, obviously. And you can use that for a lot of different ways. And you can actually add things here. I think, is it desk? Like calculating. It's calculating. That's what I wanted to write. So you can give it the description. There's a lot more that you can do. You can give it units, so that here it says, instead of seconds per iteration, you could say it, I don't know, to stay on the topic. What do you have in the hitchhiker? Towels. So it's running on 1 towel per second, or 1 second per towel, same thing. And there's a bunch more that you can that you can do with it, but really what most of the time is good enough is just import it as it is there, wrap this around anything that you want to do, and you get a progress bar. And this doesn't have to be in map, so if you're still writing for loops, you can, instead of doing this, instead of just doing this and waiting till it's done, well, printing is not actually a good idea there. But similarly, if you just put tqdm around the thing that you loop over, and you get your progress bar. So yeah, that's it. Have a go, try it out.
Oh, that looks really easy and massively effective. Stop all that scratching our heads and going, should we go to the bar or should we stay and watch this?
Yeah. The thing is, this only works for stuff that you actually wrote. You can't easily inject that into, say, training of a model unless you write the training code. So if you're in the depth of, machine learning library, maybe you can, but really most of the times at the real interesting parts for machine learning, nothing happens in loops anymore, but somewhere vectorized on your GPU. You're on mute, sorry.
Oh, sorry, my son's coming and he's asking me why I've got a funny background.
Right.
Because it goes with the shirt. I suppose that's one of the really nice things about using the higher end libraries like PyTorch and Keras and FastAI is that a lot of the times those things like progress meters and stuff are all in there, baked into the system for any of the long running processes. Then you've got like TensorBoard and stuff like that where you can get really, really nice diagnostics out. That might actually be a really good topic to do, is integrating TensorBoard in and getting some good metrics out of the training. That we could maybe take that as a topic to do further down the line.
Yeah, that would be quite cool. I've always been a bit intimidated by TensorBoard, but I think only because I've never actually tried to use it. I think it's probably much easier than I think.
Yeah, it was. I managed to get it working for TensorFlow about a month after I started doing any form of deep learning. So I was a real noob at that point, and it took me a night to get working. But so if I could do it then, I'm pretty confident I can do it now, and I'm very confident you'd be able to.
Yeah, I'm pretty sure since then it's gotten even easier anyway, because they keep making things easier at every release. So yeah, it can't be that hard anymore.
Oh, good. Yeah, TensorBoard's linked into Collaboratory now. You can get all the visualizations straight in your notebook. It's so clean and easy to install now. Cool. Yeah, well, that's it. That's given us a couple of ideas of things to do. We've got we'll keep in touch over Slack. Everyone's got a long weekend and lockdown, so let's all get Kaggle accounts if we don't have them, and try at least run an epoch of training so that you can get a score and go through the process of submitting a result, and it gets you your first couple of Kaggle badges, and then let's form a team.
Sounds good.
All right, cool. All right, well, what I'll do is I'll close the recording and let everyone away early tonight. Thanks again, Elias. That was really, really solid. And if we can, when I put this up, is it okay if I post links to the notebooks?
Sorry, you were cutting out.
Oh, I was saying, is it okay to post links to the notebooks when I publish this one?
Yeah, sure. I think so.
Okay, cool. Thanks a lot, guys.
Thank you. Bye.
Cheers. Bye.